Hello, hi, welcome back. Welcome to EDUHUNT, IIT and NEET foundation classes. This is Sukumar. See, in the last class, we discussed what is hybridization, what is the need for the central atom to undergo hybridization, and what is the process of hybridization with beautiful examples. And in the previous class itself, I told you, in the next class, we are going to discuss a beautiful method to identify the hybridization of the central atom. Okay, let's start the class. How to determine the hybridization of the central atom? How to determine hybridization for central atom? See, I have told you already that only central atom is involved in hybridization. Only the valence atomic orbitals of the valence shell of the central atom will involve hybridization. Now in this class, we are going to discuss a method to identify hybridization. See, in your daily practice or in the examination, you are supposed to determine the hybridization of the central atom by just looking at the formula sometimes, or just by looking at the structure of the molecule. So you must be in a position, listen carefully, you must be in a position to determine the hybridization of the central atom by just looking at the formula or by just looking at the structure, in both ways. So I'll teach you, I'll give you best methods for both cases. Okay, let's start. So first of all, from the formula, from the formula, I'll give you one formula, or from the structure. What I am telling you, to determine hybridization of the central atom from the formula or from the structure. What I mean by this? I mean, if there is formula given to you, then how can you determine the hybridization for the central atom? Or if the structure given to you, then how can you determine the hybridization for the central atom? But do remember, in both cases, you need one thing, that is steric factor. Steric factor. In both cases, you need a concept called steric factor. Simply we indicate with the letter S. You need to calculate S value. By the S value only, you can determine the hybridization of the central atom. What is S value? S value is the steric factor value. Sir, how can we determine if you know the steric factor value? Sir, see, simply, if S value is 2, that is sp hybridization. If S value is 3, sp2 hybridization. If S value is 4, sp3 hybridization. If S value is 5, sp3d hybridization. If S value is 6, sp3d2 hybridization. See, in this, if the S value is 5, there can be dsp2 or like that, dsp3. See, you will find that hybridization in the case of complex compounds. Let's learn about simple compounds for now. If S value is 7, you can have sp3d3, sp3d3 also. Okay. Alright, no problem. If S value is equal to 7, then that hybridization can be sp3d3, sp3d3. So what is really important here is, in this class, we are going to learn how to determine the hybridization of the central atom by just looking at the formula or by looking at the structure. From the formula also you need to calculate S value. From the structure also you have to calculate S value. When you know the S value, then simply the hybridization. Do remember always, if S value is 2, sp hybridization. S value is 3, sp2, S value 4, sp3, S value 5, sp3d, S value 6, sp3d2. Okay, sir, what is S value? That is steric factor. That's the number. It's just a number. Okay, any of these values. Okay, see, in both cases you need this value. Okay, I am taking next page. The first case, from the formula. From the formula. If the formula of the molecule given, okay, or the ion, molecule or ion, see, if it is molecule, then the formula to calculate steric factor is S is equal to 1/2 times of valence electrons plus monovalent atoms. That's it. Okay, I'll write what is this V. V means valence electrons, M means monovalent atoms. I'll write separately. Sir, what sir if it is molecule? Example? Molecule. Example? Chemical species without charge. This is the example. CO2 molecule, NH3 molecule, H2O molecule, like that. Okay? Yes. Now, if it is ion, ion can be a cation or anion. Cation with a positive charge. Example? Example? NH4 plus CH3 plus, like that. Okay? Cation. If it is cation, then the steric factor, how to calculate steric factor? S is equal to 1/2 times of valence electrons plus monovalent atoms. Monovalent atoms. Now listen carefully. If it is a positive charge, then subtract the charge magnitude. That means there is 1 unit positive charge, then M minus 1. The C is the charge magnitude. Again, what happens if it is anion? What happens if it is anion? Examples for anion? Anion examples. CO3 2 negative. CO3 2 negative, NH2 minus, like that, any anion. Then how can you calculate S value? S value is equal to 1/2 times of valence electrons plus monovalent atoms. See, if it is anion, there will be a negative charge. Then what you need to do? You have to add the charge magnitude. So there is a 2 unit negative charge. You have to add 2 plus here. That means you need to add 2. That's it. So in the case of cation, you are subtracting the charge magnitude. In the case of anion, you are adding the charge magnitude. This is just a formula. These three are just a formulas. So I have given you 3 formulas. One formula is for neutral molecule, another formula is for cation, another formula is for anion. By using these 3 formulas, you can determine the S value for any molecule or cation or anion. Okay, simply S is steric factor, V is nothing but valence electrons. What I mean by M? M is equal to monovalent atoms. Monovalent atoms. Sir, what I mean by monovalent atoms? The atoms or groups. Monovalent atom or group. The atom or group which can be bonded with a single bond to the central atom. Like chlorine. Chlorine is bonded to the central atom with single bond. Like hydrogen. Hydrogen bonded to the central atom with single bond. So all those atoms or groups which are bonded to the central atom through single bond can be monovalent. Okay, and that C. C is nothing but charge magnitude. Charge magnitude. Okay. So do remember these formulas. I am going to explain I'm going to explain these formulas with particular examples. For suppose, let's take this NH3. NH3. It is neutral molecule, right? So the formula can be S is equal to 1 by 2 times of valence electrons plus monovalent atoms, right? Then apply it. So S is equal to 1 by 2 times of the valence electrons in the central atom. Central atom nitrogen is the 5th group element. The number of valence electrons is 5. Valence electrons 5 plus monovalent atoms. There are 3 monovalent atoms. 5 plus 3, 8 by 2. So the steric factor is found to be 4. It's nothing but sp3 hybridization. Okay. Now, carbon dioxide. Carbon dioxide. Again, it is neutral molecule. Again, same formula. Then apply the formula. Steric factor is equal to 1 by 2 times of the central atom is carbon, fourth group. That means the valence electrons are 4. 4 valence electrons plus monovalent atoms. M means monovalent atoms. Ikkada oxygen is divalent. It can bond with 2 bonds, right? Monovalent atom 0. Okay. Now the S value found to be 2. If it is 2, if S value is 2, then the hybridization is Sp. I have told you already. If the S value is 2, hybridization is Sp. If it is 3, Sp2. If it is 4, Sp3, like that. Okay. One more. COCl2. COCl2. Again, neutral molecule. The same formula applies here. S is equal to 1 by 2 times of, what is the central atom? Carbon is the central atom. So the valence electrons are 4 plus total number of monovalent atoms. Oxygen is divalent, but chlorine is monovalent. 2 monovalent atoms. So 4 plus 2, 6 by 2. The S value is 3. If S value is 3, the hybridization is Sp2. Again, SOCl2. SOCl2. Again, neutral molecule. Same formula applies. S value is equal to 1 by 2 times of sulfur. Sulfur is 16th group element. The total valence electrons in the sulfur is, sulfur outermost configuration is 3s2 3p4. 3s2 3p4. A total of 6 valence electron. 6 plus monovalent atoms 2 chlorine. Oxygen is divalent. So number of monovalent atoms 2. 6 plus 2, 8. 8 by 2, 4. So the hybridization is Sp3. Okay. So by simply looking at the formula of the neutral molecule, we just calculated S value. With that S value, we predicted or we determined the hybridization of the central metal atom. So these are all the examples for neutral molecule. Let's do some cations and anions also. Let's take example a cation NH4 plus. For cation, what is the formula? S is equal to 1 by 2 times of valence electrons of the central atom plus monovalent atoms. Now it is a cation, you subtract the charge magnitude. Now apply the formula. How the S value will be here? 1 by 2 times of. The nitrogen valence electrons are 5 plus, in the valency shell of nitrogen, 5 electrons. And monovalent atoms, there are 4 hydrogens, 4. And you need to subtract 1 unit charge, right? Because 1 plus. Now 5 plus 4, 9, 9 minus 1, 8, 8 by 2, 4. The hybridization is Sp3. Okay? The hybridization is Sp3. And CH3 plus, again one more. So same cation, same formula. Apply the formula. S is equal to 1 by 2 times of carbon valence shell electrons are 4. 4 valence shell electrons plus there is a 3. There is a 3 hydrogens, 3 monovalent atoms. minus 1, 1 unit positive charge. If it is positive charge, you subtract the charge magnitude. If it is negative charge, you add the charge magnitude. That's how the formula is. 4 plus 3, 7. 7 minus 1, 6. 6 by 2, it is 3. 3 means sp2 hybridization. Okay? Yes. H3O plus S is equal to same formula. Cation means same formula. Apply the formula. S is equal to 1 by 2 times of, here the central atom is oxygen. Oxygen valency shell you are having 6. 6 plus how many valence electrons? 3. And the charge magnitude is 1. So minus 1. 6 plus 3, 9. 9 minus 1, 4. 4 by 2. Sorry, 6 plus 3, 9. 9 minus 1, 8. 8 by 2, 4. sp3 hybridization. Okay. So this is how you can calculate the steric factor for any cation, and with that steric factor you can determine the hybridization. Okay. Next, let's do for anions also, some anions. Any anion also. CO3 2 negative. CO3 2 negative. What is the formula to calculate steric factor for anion? Half into valence electrons of the central atom plus monovalent atoms plus charge magnitude. Because it is anion, the total charge will be subtracted here. There is 2 unit negative charge. Then, sorry, so I spoke, see, I pronounced it as. See, if it is anion, then the charge magnitude has to be added. Okay? If it is anion, charge magnitude has to be added. If it is cation, the charge magnitude has to be subtracted. It is anion, so I added the charge. Yes. S is equal to 1 by 2 times of, carbon is the central atom. So the valence electrons is 4 plus. There is no monovalent atoms. Number of monovalent atoms is 0. Oxygens are divalent. Now it is anion. So I am adding the charge. How much charge? 2. Okay. So 4 plus 2, 6 by 2. It is 3. That means sp2 hybridization. sp2 hybridization. And SO4 2 negative. SO4 2 negative. S is equal to, same formula, anion, same formula. Apply the formula. S is equal to 1 by 2 times of, the valence electrons of sulfur is 6, 3s2 3p4. 6 plus monovalent atoms are 0, no monovalent atom, plus 2 unit in charge I need to add here, plus 2. 6 plus 2, 8, 8 by 2, 4. So if the steric factor is 4, it is sp3 hybridization. Okay. Similarly, NO3 minus, same anion, same formula. So S is equal to 1 by 2 times of, here nitrogen is the central atom. So the valence electrons in nitrogen is 5 plus, there is no monovalent atoms, 0 plus 1 unit negative charge is present. So add 1 unit charge magnitude. 5 plus 1, 6. 6 by 2, 3. sp2 hybridization. Similarly, I will do it for NO2 minus. I hope you know this is nitrate. This is nitrite. Don't worry if you don't know. Okay, you will come across these species in the future classes. Again, S is equal to 1 by 2 times of, number of valence electrons in nitrogen 5 plus monovalent atom 0 and 1 minus. That means I am adding 1. Again same, no change. See, even if there is a divalent oxygen 3 or divalent oxygen 2, What makes the difference? Because we are not going to consider the divalent anyway. So NO3 minus or NO2 minus both will give you the value 3. It means the central nitrogen there is sp2 here, sp2 here. Okay. So this is how you can determine the hybridization of a neutral molecule central atom or a cation central atom or anion central atom. But in the beginning, I have told you that we must be in a position to determine the hybridization of the central atom by just looking at the formula or by looking at the structure. Okay, now I'll teach you how to determine the hybridization by just looking at the structure. For that also you need S value. But here S value can be calculated by just looking at the structure. From the structure, then how to calculate the S value by just looking at the structure? S is equal to number of sigma bonds plus lone pairs. That's it. Number of sigma bonds plus lone pairs. I have told you previously that hybrid orbital only forms sigma bond, and hybrid orbital, so while intermixing atomic orbitals with half filled or atomic orbital with full filled atomic orbital or half filled atomic orbital can intermix. So when a full filled atomic orbital participates, that hybrid orbital also going to get the full pair. So what is important really here is, for every lone pair you need a hybrid orbital. For every sigma bond you need a hybrid orbital. That's how the formula is made. So from the structure you can determine the S value by just looking at how many sigma bonds and how many lone pairs. Okay, again if this value is 2, sp, if S value is 3, sp2, if S value is 4, sp3, same. Okay, example. Now previously I have given you NH3, NH4 plus, but if you know the structure, see, after valency shell electron pair repulsion theory completion, we completed Vesper theory, valency shell electron pair repulsion theory. After completion of that theory, we must be in a position to propose structure for any molecule given to you, any formula given to you. So if you know the structure, then simply count the sigma bonds. I have told you already, single bond is always sigma. So S value is equal to, there is 4 sigma and you find 0 lone pairs, no lone pair, 4 plus 0, 4. The hybridization is sp3. Similarly, NH3 with lone pair. Now if you know the structure, if you know how to draw the structure for this NH3, then count the S value. S is equal to single bond sigma lone pair. So 3 sigma plus 1 lone pair, again 4. 4 means sp3 hybridization. Okay. So when you find a structure, when a structure given to you, simply count how many sigma bonds are there and how many lone pairs are there. So total number of sigma bonds plus lone pairs gives you S value. Or if you don't know the structure, then simply go by the formula. I have given 3 formulas for determining S value for a neutral molecule or cation or anion. Okay? Yes. See, for suppose sulfuric acid. Now from formula, if you know the formula, what is the formula? H2SO4. Sulfur is the central atom. So S value is equal to 1/2 times of the valence electrons in sulfur is 6. 6 plus number of monovalent atoms 2. Don't bother about divalent atoms. 6 plus 2 8. 8/2 4. So hybridization is sp3. So this is from the formula. This is by the formula. Then what? What if you want to do it from the structure? From the structure. From the structure. Then if the structure of sulfuric acid will be like this, then go for it. Then S is equal to number of sigma bonds plus lone pairs. Sigma, single bond sigma, single bond sigma, and I told you when there is single bond sigma, double bond 1 sigma 1 pi, triple bond 1 sigma 2 pi. So in this double bond there is 1 sigma. In this double bond there is 1 sigma, and you can see there is no lone pair left on central atom. So total of 4 sigma bonds plus 0 lone pairs. So S value 4. The hybridization is sp3. So the structure or the formula both are telling you that in sulfuric acid the central atom is undergoing sp3 hybridization. Okay, you may or may not know the name. Okay, yes. Similarly, you can go for the phosphoric acid or carbonyl chloride. Carbonyl chloride. Don't worry if you don't know the name. Okay, you are not supposed to know the name for everyone, right? Yes. I will give you the formula for it. COCl2, COCl2, C capital O, Cl2. What I mean by this? Here the central atom is carbon. S value is equal to 1 by 2 times of carbon valency shell. There is 4 electrons. 4 plus, there is 2 monovalent atoms. 4 plus 2, 6, 6 by 2, 3. 3 means sp2 hybridization. Now what happens? What you have to do if you know the structure? The structure of COCl2 can be like this. See, you can do this only if you are able to draw the structure, otherwise you can't do. You go by the formula. COCl2. Single bond sigma. Single bond sigma. In double bond there is 1 sigma. 3 sigma. So S value is equal to 3 sigma, 0 lone pair 3. It says it is sp2. So the structure and the formula both are saying that COCl2 is in COCl2 the central atom is undergoing sp2 hybridization. Okay, and sulfonyl chloride, like the formula is SOCl2. The formula is SOCl2. So if we count the S value 1 by 2 times, sulfur is the central atom 6 plus monovalent atoms 2. 6 plus 2, 6 plus 2, 8, it is 4 sp3 hybridization, SOCl2. The central atom is. Now what about the structure, sir? Structure will be like this. Okay. In the valency shell of sulfur there is a, see sir, you may ask me that, sir, how can you draw the structure from this, sir? See, you may forgot Vesper theory, but I don't forget, na? So because I am daily teaching. So you are not supposed to forget the concepts you have learned about Vesper theory in the previous classes. By the knowledge of Vesper theory, we are in a position to propose a structure to any molecule or ion given to you, right? So by just simply seeing it, I propose this structure. In the valency shell of sulfur, there is 6 electrons. 1, 2, 3, 4, 5, 6. Okay. And simply S value is equal to number of sigma bonds plus lone pairs. Single bond sigma. In the double bond, 1 bond is sigma and 1 lone pair. So there is 3 sigma plus 1 lone pair. So steric factor is coming to be 4. So the hybridization is sp3. Are you getting what I am saying? Okay? Yes. Similarly, phosphoric acid. Sir, what is phosphoric acid, sir? H3PO4 is phosphoric acid. H3PO4 is phosphoric acid. Now you see the formula. S is equal to 1 by 2 times of central atom phosphorus is 5th group element, 5 valence electrons plus number of monovalent atoms 3, 5 plus 3, 8 by 2, 4. So the hybridization is sp3. Don't bother about the bivalent oxygen. So central atom valence electrons in the central atom plus monovalent atoms. Well, it is a neutral molecule, don't bother about the charge. If there is a charge, do you remember? If there is charge for cation, subtract the charge magnitude from the formula. If it is anion, subtract the add the charge magnitude. Okay, I told you previously. Now, sir, what if you know the structure? H3PO3 structure will be like this. H3PO3 structure will be like this. Count the sigma. Sigma, sigma, sigma. In the double bond, 1 sigma, you find no lone pair. So, S is equal to 4 sigma plus 0, 4 sp3. Structure also giving you the steric factor value 4. Are you getting? Yes. Now, H3PO3. See, H3PO4. What you get? S is equal to 1 by 2 times of phosphorus central atom 5 plus monovalent atoms 3, 5 plus 3, 8 by 2, 4. Okay. Now what I did here? I decreased one oxygen. But what happens if you increase oxygen or decrease oxygen? Because oxygen is a bivalent. In the formula, we are not considering bivalent, na? We are considering only monovalent. So again, S value coming to be same. So S is equal to 1 by 2 times of the central atom is phosphorus, valence electrons 5 plus monovalent atoms 3. That's it. 4 sp3 hybridization. Okay. So you must be in a position, the conclusion of this class is you must be in a position to simply determine the hybridization of central atom of a molecule or a ion, whether it is cation or anion, by just looking at the formula or by just looking at the structure. In both cases, you have to first determine the S value. And that is very simple. I have explained with a huge number or good number of examples. Okay. Thank you so much.